TSQL, or single server interview questions and answers. 60. Explain included column in non-clustered index. Included column is only available to the non-clustered index and do not available to the clustered index. When we create non-clustered index, we add in some key columns in the index, but they have some restrictions in the number, type, and size of the columns. So we want to overcome these restrictions, so we add some non-key columns to the non-clustered index. This is called included columns. Included columns just saved at the leaf level page. 70. What's bookmark lookup situation and how to remove the bookmark lookup? Sometimes the non-clustered index do not cover what we want to query. For example, this table just have non-clustered index, but we want to select ID, display name, and age. Some of them do not covered in the non-clustered index. So first, SQL Server use the non-clustered index, but because some of them do not in the non-clustered index, so server had to jump to the clustered index when the table has clustered index, or just use the heap table because the table might do not have clustered index. So this is called bookmark lookup or key lookup. How to remove the bookmark lookup means that when we add our columns what we select to the non-clustered index, and then the SQL Server will use the non-clustered index directly to the columns, so we can avoid the non-clustered index or just a bookmark lookup, key lookup. 18. What is CDC in SQL Server and how to implement in SSIS? Here we just talk about what is CDC. CDC is change data capture. So it's a set of software design pattern used to determine the data that is changed so that action can be taken using the change in data. Sometimes when we want to modify the OLAMP data to the data warehouse, and during this process we need to exchange and transaction and loading the data. So this process has the function of change data capture function. We capture the data change and do some actions. 19. OLAMP, data warehousing and data mart. OLAMP is online transaction processing. It's usually at the operational data part, and usually it just write and write into the data. Sometimes they use very simple queries and do not use the aggregation. It usually fast and use little space or small space. So its design is highly normalized with many tables. For OLAP, it's just an online analytical processing, just like the data warehouse. Usually, it's used the historical data to do some analysis job. So OLAP help us planning, problem solving, and decision support. So it usually use multi-dimensional views of various kinds of business activities and use the complex SQL queries and usually use the aggregation functions. So it usually slower than OLAP system and usually use the bigger space because we need to have some aggregation structure and historical data and more index than OLAP. So for the database design, OLAP typically denormalized with fewer tables, use star and snowflake schema. Well, for data warehousing, it's the process of constructing and using data warehouse. Data warehousing usually used for analysis, reporting, structure, and ad hoc queries. So it's usually store the historical data, just like a container. Data mart. Here is the picture which shows the data method warehouse for the data source from OLAP, and then we stage some address and send to the warehouse. For example, a company have the company database. For company usually have the purchasing part, sales part, and inventory. So every subset of the data warehouse is the data mart. 20. Primary key, unique key, composite key, surrogate key, and natural key. First, primary key. A table just only have one primary key. Primary key contains the uniqueness of the columns, so it cannot be null and cannot be duplicate columns. Duplicate rows. Unique key is considered to be the primary key, but because one table just one primary key, so it cannot be the primary key or do not choose to be the primary key. Well, unique key also shows the uniqueness of every rows, but the difference is unique key can have more than one unique key and it can be none, but unique key just can have one none. And usually, a unique constraint will generate unique non-clustered index. For composite key, it's just for more than one columns. For example, student ID and subject ID, and they are the composite key. So the marks and exam scores depends on student's ID and the subject ID. For surrogate key just a system generated columns. It do not have any basis meaning. This is the surrogate key. For natural key is the column. It have the actual basis meanings. That is the natural key. 21. Relationship one-to-one, one-to-many, and many-to-many. For one-to-one relationship, both of them talked about the two tables. One-to-one relationship, for example, we just take one table for every row of the table. It has only one rows matched in the other table. This is the example for students and the students' contact information. So the primary key both are the student's ID. So every student in table students have only one student's ID matched in a constant information. They are the one-to-one relationship. So for one-to-many relationship, it means that for the two tables, one row have more than one table matched, one row matched in the other table. And the customers table and the orders table, every customer in customers table might have more than one orders. So this is the one-to-many relationship. For many-to-many relationship, sometimes students they can have more than one class, and one class can have more than one students. So students and the classes, they are many-to-many relationship. At this part, we need to add into a table, have the student's ID and the class's ID as the foreign key, and they jump together and change the many-to-many relationship to many-to-one relationship. 22. ER diagram. ER diagram is the entity relationship diagram, also known as ERD, ER diagram, and ER model. It's a type of structured diagram for use in database. It just shows the entity and the relationship between them. This is the ER diagram. 23. Logical, physical, and conceptual model. This is just the model we decide for software. First, the conceptual data model. This is the highest level relationship between different entities. It just shows the entities and the relationship, kind of relationship between them. So at this level, we do not have any columns. We just have the entities and the relationships. For the logical data model, we added into the column names or attributes into the relationship, and into the entity, and we make sure what kind of relationship they are. So at this part, normalization occurs, and we have the primary key, foreign key, such kind of structure in the ER model. And for the physical data model, we get more detailed information into the model. We have the denormalization here, and we have the data type, constraints, and length, such kind of information. This part still the problem of how the database will be created. 24. Reverse forward engineering. Forward engineering, we can see it's just from the system specification to the design and implementation to the new system. And we can see forward, it just from the conceptual or ER diagram to model, and from model to database. So it needs higher technology and longer time. But for reverse engineering, it's just from the existing software to understanding and transformation and to re-engineering systems. So for reverse engineering, it's just being backward engineering. So it's easier, do not need such kind of techniques and not so much times. 25. Normalization and the first, second, and third normalization form. Normalization is just to reduce the redundancy, and it's the process of dividing the data into multiple tables. So it's for the first normal form, we just need to remember that it's atomic, and it cannot have the same column names. For the second normal forms, it's based on the first normal forms, and it's cannot have the composite and partial dependence together. So for the partial dependency, it means that uh, for example, this name depends on the customer ID. This is the partial dependency. For the third normal form, it's based on the second normal form, but we want to remember that it do not have the transitively dependent. For example, the course name depends on the course code, and also course code depends on the unit code.